Hello, and today we're talking about 8.4 and 8.5. This is area between two curves. Um, Really what's going to happen in this unit is we're either going to have two equations in terms of x or two equations in terms of y, and we're going to find the area between them. So we understand that when we're integrating, let's say this is f of x. If I integrate f of x from A to B, that is essentially the area under that curve all the way up to the x-axis. Now, what ends up happening with area between two curves is I'll also have this g of x, okay? Now, this g of x will have this area here and this area here, kind of coming with the x-axis, and we'll stop it there. Now, if I'm trying to find the area between these two curves, what I'm going to do is I'm going to take my top curve minus my bottom curve, and I'm going to subtract that. So I'm going to integrate f of x minus g of x dx. So it's all of our, if I can write a dx, it's all of our integration rules we already know, except a couple things. One, unlike area under a curve, area between two curves, always positive. For example, I could have something where my top curve's here, my bottom curve's here, and regardless, this will end up being a positive area because what's happening with that is here would be your first curve, here's its area, and then we're going to subtract, we're going to take away this area. So even though this bounded region would have a negative area, we're subtracting the negative area, thus creating a positive area. Okay? So we need to first figure out, are we dealing with this as a vertical or horizontal? Most of the problems we're going to deal with today will be vertical, and then we'll move our way to horizontal. So top curve minus bottom curve, but sometimes we're also going to have to break it up. So for example, we have this function, we have this region R where we have f of x and g of x, and we realize that they intersect at this point 4 comma 2. Sometimes with the AP test, they'll tell you the point. A lot of times they'll give you a picture, but it's not a guaranteed. They'll tell you what that value is. Sometimes they would just say, hey, we know they intersect. You got to find out where. In that case, we'd have to set square root of x equal to 6 minus x, square both sides, and then solve. This would give us x minus 9 and x plus 6, or sorry, plus 4. No, minus 4. There we go. And the 4 is the only one that actually works as a solution set. So 4 would be our intersection point. In this case, to figure out the area of R, we're going to have to separate it into two separate functions, two separate integrals. We're going to have this splitting at 4. So our first function is going to be the integral from 0 to 4 of f of x, which is just square root of x dx, plus, and then we're going to split it to a second function, which is 4 to 6 of g of x. Now, you will note that I have talked about, hey, just name this f of x and name this g of x. And if your job was to just write what the area under the curve would be, I totally agree with putting that there. However, because this one actually wants you to integrate, I'm going to just write the function. Take a second and stop and integrate this. And when you're done, come back. Okay, we're going to integrate this, and this is going to give me x to the 3 halves times 2/3 from 0 to 4 plus, and then you can either make this 6x minus x squared over 2, or you can kind of do power rule for the whole thing. I personally like us trying to get more towards power ruling the whole thing because that's going to be easier overall. I'm going to divide by -2 because of the negative here and the exponent here. I'm going to evaluate from 4 to 6. And again, that's also especially like helpful when we're doing our separation of variable like we did in Unit 7. It's kind of better just to get in the habit of power rule. I plug these in. That gets me 2/3 times 4 to the 3 halves, which is just going to be the square root of 4 cubed, or 8 times 2/3, which is 16/3. And then plugging this in, I'm going to get plus 6 minus 6, which is 0 squared over negative 2. And then a minus plugging 4 in, that's 2 squared over negative 2. So really, I'm going to get 16 thirds. And then this goes away. And this will become plus 2. If this is a multiple choice question, you need to get it all the way down to 22 over 3. If it's an actual FRQ, this, or even technically this, would be a fully acceptable answer. Okay, notice there wasn't any vertical overlap here, so we didn't have to worry about top minus bottom, but we'll see some of those here in a second. And here's the answer. 1 point for the integral, 1 point for the antiderivative, and 1 point for the final answer. They ended up, if you see this answer right here, this 1/2, 2 times 2, they just took this and made it like a triangle, which remember, we can still do that if it's area under a curve. If we can do geometric shapes, you're legally allowed to do that. So keep that in mind. All right, next one. Here, we do not have to break up our integral because they don't intersect at, or they overlap each other. They also don't intersect at multiple points, but we'll get to that in a later unit or a later lesson. Here we can just say top curve minus bottom curve. Now, they are giving us a picture of this. And while that might not be super easy to see, I think we should be okay with like realizing the quadratic that opens up is the bottom curve. And the cosine starts here and kind of goes down like the wave. But let's say you don't have a picture, or that's not at the top of your brain. How do you figure out which one is the top function, right? So what I do is I look at this and go, okay, well, I'd have to be told they're intersecting at 0 and 2, because there's no way I can set f of x equal to g of x. Like, I'm not solving this without a calculator. That's not happening. With a calculator, no problem, but without a calculator, I can't solve that. But from here, if I go, okay, well, I don't know which one's on top. All you have to do is plug a value between the two bounds. So in this case, between 0 and 2, and whatever has the bigger y value is the top function. So what's a good value between 0 and 2? 1. So if I plug f of 1 in, I'm going to get 2 minus 6 plus 4, which is equal to 0. And then if I plug this into g of x, I'll get 4 times the cosine of pi over 4, which is just 4 times radical 2 over 2, which I think we're cool being bigger than 0. So this tells me g of x has to be on top. The setup for this is going to look something like the integral from 0 to 2 of g of x minus f of x. And make sure you put this in parentheses. It's always sad when students get this wrong because they just put the minus in front of the 2x squared and they're not willing to distribute it correctly. Okay, so that's our first piece. Secondly, take a minute, by hand, I know crazy, try to find the antiderivative here. Okay, if you did it correctly, it should look something like this. So they put the two functions. Here we have that times 4 over pi because of the linear term here, right? So it's the reciprocal of that. And then this is just power rule, power rule, power rule. Next, we plug in the 2 and 0. And we do need to simplify down the sine of pi over 2 and sine of 0. We always have to simplify with trig functions. I couldn't care less if you simplified this down to 4/3. Again, remember, calc and active, you box that final answer. Do not simplify down here. I don't want to see it. Okay, so this one is a setup, but do not integrate. And this is exactly like the problem we had before. However, here we have these bounds that aren't necessarily our endpoints, right? They don't necessarily intersect at 1 and 4. We just say that these are our end bounds. Now, these two functions, there's no way for me to set this up without a calculator. Say, when does natural log of x equal 3 sine of pi x plus 6? Like, I'm not going to calculate that. But I do have the ability to figure out which one's on top. how could I figure out which function's on top? That's right. All we have to do is plug a value in between 1 and 4. Pick a nice value. Pick something that you might be able to use or just in general kind of have an estimate of. I like plugging in, for example, something like 2. I think 2 is an easy value to get. Because these aren't necessarily endpoints, you could also just plug in 1 or plug in 4. I'm going to go with 2 because that should work as well. F of 2 is the natural log of 2, which I don't know what that is, but I know the natural log of E is 1, and 2 is less than E. So this has to be less than 1. So whatever my answer is for G, I know that if it's bigger than 1, it automatically wins. Then G of 2 is equal to 3 sine of 2 pi plus 6. Oop. The sine of 2 pi is 0, so G of 2 is just equal to 6. 6 is bigger than 1, so G of x is on top. Now again, watch, this asks me to write but don't evaluate. So I'm going to just say integral from 1 to 4, and this will be G of x minus f of x dx. Now, I do not know if they intersect more than one time. If they intersect somewhere between 1 and 4, there's no way I can figure that out without a calculator. Sometimes what we'll do, so that way we don't have to worry about this, is we'll throw absolute values around them. The reason we throw the absolute value is because if that area was negative, for example, this would give me a area that would be positive. So we're able to kind of switch that around. Right now, don't worry about that, but we'll get there. Okay? All right. Here, find the area in the first quadrant bounded by y equals e to the x over 2 and x equals 2. So this is still technically an area between the curves because you're bounded in the first quadrant. So what this means is you kind of have the second line of y equals 0. And so your e to the x function looks something like this. And we're bounding it from x equals 0 to x equals 2. And we're just saying our top curve is this e to the x over 2, and our bottom curve is 0. So our integral is going to look something like 0 to 2 of e to the x over 2 minus, oh, I accidentally went the wrong way. Undo. No, redo. Okay. Minus 0 dx. The minus 0 is being a little bit extra, but sometimes it'll say like bounded by the line y equals -4 or something like that. And then you kind of have to know which one's on top, which one's on bottom. This would integrate to e to the x over 2 times 2 because reciprocal of the coefficient. Coefficient there is 1. Or sorry, the coefficient there is 1/2. Sorry, clicking too many places. And then I plug in 0 and 2. This becomes 2e to the 1 minus 2e to the 0. And so I end up with 2e minus 2, or A. All right. Okay, we got one more. We're going to determine the area connected by these. We're also going to set up but not integrate, which means that we need to essentially figure out where these two intersect. So figuring out where these two intersect means I'm going to set this equal to this. And now we need it to equal 0, so that way we can actually solve. And we get 2x cubed. 2x cubed. The x squares will cancel, and we're left with a minus 8x. I can factor out a 2x, and I'm left with x squared minus 4. So I kind of have a bunch of bounds here. I have 2x equals 0, x minus 2 equals 0, and the x plus 2 equals 0. These two are coming from the x squared minus 4. So I get x equals 2, x equals -2, and x equals 0. Now, my goal is to set up but don't integrate. So this is where I might make this a little bit easier on myself. And I will just go -2 to 2. And then I'm going to pick a function on top. It will not matter. And I'll have something like this, and then minus that whole quantity. Notice I could have reversed this with the absolute value. Now, let's say you're not allowed an absolute value. Let's say this is like a multiple choice question, right? And you're not allowed an absolute value. Once you know that these are your bounds, the 2, -2, and 0, you then have to just plug in and figure out which one's on top, which one's on bottom. The good thing is essentially what we're saying by plugging these in multiple times is that they're going to cross. We just have to figure out which one's on top first. So let's say I plug in like x equals 1, because 1's between 0 and 2. If I plug x equals 1 into this first equation, I would get -1 plus 3, which equals 2. Plugging 1 into the second equation, I would get 2 minus 1 minus 5, which equals -4. 2 is bigger than -4, so this function's on top between 0 and 2, which means more than likely, not 100% of the time, but more than likely, our other function's going to be on top the second half. So that means from 0 to 2, I'm going to use the x squared on top first, -x squared plus 3x, and then minus that whole second function. And then for the first chunk, from that -2 to 0, I'm going to do the 2x cubed. If I had plugged in -1, I would find that this was the case, that the functions do switch and we get the cube on top if I plug in the -1. If we want to do this first quadrant, this entire first chunk goes away, right? That whole first chunk goes away. We would no longer need to worry about it. Okay? But otherwise, everything else would stay the same. This can be a bit of a bear if you have to calculate this by hand. I would wholly suggest simplifying that down first, and then that way you're only integrating 3 terms. If you don't simplify down first, not only are you having to integrate 5 terms, you then would have to plug in 5 terms. And that's fair. No one wants to do that. Okay? All right. This one I think we're going to have to do together. So we're going to call it here. I think this is a hard one to go with. So we will save this for class on either Wednesday or Thursday. One of the two. All right, hey gang.